All right, this last part is kind of the application of this natural number e. So the formula for a continuously compounding interest formula, so it's a equals p times e to the rt power, where a is the total amount, p is the principal, the starting amount, r is the annual interest rate, and t is the time in years. So continuously compounding means it's literally gaining interest every instant, not just like every second or every hour. Literally every instant it's gaining more interest. Now it's hard to divide it down into the smallest instant that you can get, but it's continuously gaining money. So here's an example. We've got what's the total amount for an investment of $500 invested at 5.25% for 40 years compounded continuously. So we got the formula A equals P times E to the RT power. A is the amount we're looking for. P is the initial amount, the principal, which is $500. E is the number E. We'll just use the calculator for that. R is 5.25%. But thinking back to what we've done with interest in the past, remember when we're putting putting percents into equations, we're going to have to convert them to decimals. So we're going to make it 0.0525. And then T is the amount of time in years. So we're waiting 40 years to see how much interest or how much total money we'll have. We got 500 times E, and then our exponent is 0.0525 times 40. So make sure when you type that into your calculator that whole 0.0525 times 40 is your exponent. If you're using an older calculator, just make sure that whole group is in the parentheses. And after you go through all that, you find out you have A equals $4,083.08. So just by letting it sit for 40 years, it's more than octupled its total amount. Now we're going to look at one more example. This one's going to be solving for a variable, not just plugging stuff in. It says, how long will it take for the account from the previous question, the one where we start with $500, to reach $5,000? So again, we're going to use that same formula. We got A equals P times E to the RT power. In this case, we know our final amount is 5,000. We know our principal amount, it's the same as last time, it's 500. We know our R, same as last time, 0.0525. And what we don't know is the T. So we're going to figure out how many years it's going to take. So let's plug in what we know. We got 5,000 equals 500 times e to the 0.0525 t power. Now to start solving for t there, we got to get rid of everything on that side except for t. We're going to start by dividing by 500 on both sides. Now 5,000 divided by 500 is 10. And on the right side, we're left with just e to the 0.0525t. Now, going back to a property that we looked at earlier, the natural log, looking at these, the natural log of e to an exponent just simplifies down to the exponent. For our example here, we're trying to get the exponent all by itself. So what we're going to do is let's take the natural log of both sides. So just like you can take the square root of two sides of an equation, you can take the natural log of two sides of an equation. Now, the left side, we're just going to leave that as the natural log of 10 for now. On the right side, the natural log of e to the 0.0525t is just 0.0525t. Now again, the natural log of 10, you've got a button for that in the calculator. That's that ln button that we used earlier, but we're using it for the purposes of, like we press second and then ln, but now we can just press ln. Now to solve for t, we're going to divide both sides by 0.0525. And on the right side, we're left with just t. And on the right side, on the left side, I probably should put a squiggly equals because we're about to round. On the right, I can't get my left and right. On the left side, we got 43.859, and that unit is years. So it's going to take 43.859 years for it to reach $5,000.